We are here today to propose a switch from the conventional fossil fuels to more environmentally safe sources. We here at Fission Tech believe that nuclear power is the most sound option for a prosperous future for our country. It will severely diminish our carbon footprint, decrease our impact on ecosystems, and be an overall improvement for this country. Converting our power production to nuclear power would also mean a diminished demand for fossil fuels, causing them to be available farther into our future. Nuclear power comes from two types of reactions: nuclear fusion and nuclear fission. Nuclear fission is what technology can now sustain. It works by following the same steps as fossil fuel power, except rather than having the burning of fossil fuel create the steam, the decomposition of the chosen elements fuels the steam. As the radioactive element deteriorates, usually uranium or plutonium, heat is given off as a product of the element breaking down. This heat turns water into steam, and the steam then is used to run steam turbines that create electricity. Nuclear fusion, on the other hand, works by the combining of two hydrogens at very high speeds and high heat to produce a larger element. The process of the two atoms conjoining gives off a great amount of heat that can be captured and used to create steam just like fission. Scientists, as we speak, are working to crack the code. However, the need for extreme temperature is the main setback. Nuclear fusion would be the better of the two, due to us not having to store radioactive elements, but for now is out of our technological capabilities. Nuclear power is more ecologically safe, because rather than have carbon dioxide waste being produced, it produces decomposed uranium and plutonium that can be stored. Instead of the waste being dumped into the environment, depleted elements can be stored. And if we were to discover how to effectively create nuclear fusion reactors, there would be almost no waste at all. This would greatly decrease the amount of pollution, which is steadily increasing under our use of fossil fuels.
Not only do we as a country, but we as a species need to consider how we're collecting our energy and our way of life impact the world around us. We currently are responsible for non-point source pollution. Now, you may ask what this is. It's fertilizer from our lawns, oil from our cars, and sediment from the ground. You may ask how this happens? Well, we have no trees to anchor this sediment in. So, when the water runs past it from the rain, we're losing fertilizer, oil, and, and sediment into our waterways. You could always assume that that's not a good thing. Well, here's why. When it gets down to the Gulf of Mexico through either the Mississippi or if you're near there, just runs off naturally. Well, the Carina brevis is affected, and it's a critical species to some areas. It's so important because without it, there's no life, but with too much of it, there's also no life. It's an autotroph, meaning that it takes sunlight, converts it to energy through photosynthesis, and then that energy is passed up the chain into things that we like to eat. Now you may be thinking, well, this is great. We should make sure that this stays around. Our our fertilizer is making it so it explodes in population and dies off. It causes these red tides. Red tides are blooms of this species that get so populous that they change the color of the ocean. Keep in mind, these things are microscopic. We'll get into their exact size a little bit later. Red tides are so dangerous to the organisms that live in the water because when it gets into such a high concentration, the toxins that these organisms release get deadly. And without them, everything collapses. You may ask, well, what did we do? Nitrogen from fertilizer makes it exponentially grow into these tides. And when this tide comes to fruition, a dead zone appears. This dead zone could either last forever or go away. Now, dead zones are an interesting topic because it surrounds a bloom, a brevis bloom. The brevis blooms, which kills off everything in the area if it gets to a too high concentration. That's terrible. Now, when the bloom dies, you'd expect everything to come back because there's nothing left to kill it. Except the decomposers inadvertently destroy that chance. When they decompose that bloom, they use up all the oxygen. Now, with no oxygen left, how do you expect any species to survive? Well, they can't. And even if they don't want to return in full population, if an organism comes into this dead zone that needs oxygen, if it doesn't realize, it can suffocate and die. Now, where this lives in the Gulf of Mexico, surrounding Florida, and it can go as far north as North Carolina. So while it's not an impact to us, it's an impact to our way of life, as fishing is a large portion of that area. Now, here's the life cycle. As it's a photoplankton, there are a few ways that it can go about reproduction. The main way is number one, which is binary fission. I'm sure you all know about this, but it's when one cell grows and then splits into two. Another option is sexual reproduction, in which two different brevis come together and make more. I'll skip the other three because they're in such low concentration, it's a little bit pointless to discuss. Now, if you were able to obtain some Carina brevis, you would be able to see that it has two flagella, which are appendages on its circular body that allow it to move through the ocean. Now, as I talked about earlier, it's tiny. It's 20 to 45 micrometers long and 10 to 20 micrometers deep. It's not a large thing we're talking about. Now, the impact of the toxin. It takes care of everything in its path. Well, you may think, oh, but it's fine. It's just that area. Except some of these organisms we like to eat up here. And if you eat something that's killed by this bloom, you can be poisoned. You can have respiratory problems if you eat something that is affected by this bloom. It's an issue that affects even us as humans. Now, here's a sample food web. The Carina brevia in the center. Now, that takes care of the sunlight. Comes in, turns into energy, and then it's either eaten by the menhaden or the giant whale shark. If it's eaten by the giant whale shark, it'll go mostly undisturbed. It'll go through its life. But when it dies, bacteria take care of it. And that keeps the cycle, goes back to the cycle. The brevia could get eaten by a menhaden, which could either die naturally from it and go back to the bacteria, or it could get eaten by tuna. And the tuna could die, or it could get eaten by a bull shark. And from the bull shark, it could die as well. Everything goes back to this bacteria that's going to eat up the oxygen in the area. And with the brevia taking care of it, it's going to run out eventually. As the brevia runs out of nitrogen that we've supplied it, it dies out, and then it rushes to the bacteria as well. It just ends off the area. Now, that's the reason why we have to take control of our actions. If we don't, we may not have the same ecosystems that we have today.